A decision tree is a type of machine learning model and decision support tool that uses a tree-like structure to represent decisions and their possible consequences. It's used for both classification and regression tasks. Import pandas as PD. This line imports the pandas library, which is essential for working with data in a structured way, especially in the form of data frames. We'll likely use it to load and manipulate the dataset. Asterisk from sklearn. Tree import decision tree classifier. This line imports the decision tree classifier class from the sklearn tree module. This is the core class we'll use to create our decision tree model. Asterisk from sklearn. Model underscore selection import train underscore test underscore split. This line imports the train underscore test underscore split function from sklearn model underscore selection. This function is crucial for splitting our dataset into training and testing sets to evaluate the model's performance on unseen data. Asterisk from sklearn import metrics. This line imports the metrics module from sklearn. This module provides various functions for evaluating the performance of machine learning models, such as calculating accuracy. Feature underscore calls equals pregnant, insulin, BMI, age, glucose, BP, pedigree. This line creates a list named feature underscore calls containing the names of the columns that will be used as features, independent variables, to predict the target variable. Notice that skin is missing from this list compared to call underscore names. Asterisk x equals PIMA, feature underscore calls. This line creates a new pandas data frame named x containing only the columns specified in feature underscore calls. This data frame will hold our feature data. Asterisk y equals PIMA, label. This line creates a pandas series named y containing the label column from the PIMA data frame. This series will hold our target variable, the variable we want to predict. Asterisk x underscore train, x underscore test, y underscore train, y underscore test equals train underscore test underscore split, x, y, test underscore size equals 0.3, random underscore state equals 1. This line uses the train underscore test underscore split function to split the dataset into training and testing sets. Asterisk x, the feature data. Asterisk y, the target variable. Asterisk test underscore size equals 0.3. This specifies that 30% of the data will be used for the testing set, and the remaining 70% will be used for the training set. Asterisk random underscore state equals 1. This argument sets a seed for the random number generator used during the splitting process. This ensures that the split is the same every time the code is run, which is useful for reproducibility. Asterisk the function returns 4 variables. Asterisk x underscore train, the feature data for the training set. Asterisk x underscore test, the feature data for the testing set. Asterisk y underscore train, the target variable for the training set. Asterisk y underscore test. Asterisk CLF equals decision tree classifier. This line creates an instance, an object, of the decision tree classifier class. This initializes our decision tree model with default parameters. Asterisk CLF equals CLF.fit, x underscore train, y underscore train. This line trains the decision tree classifier using the training data. The .fit method learns the relationships between the features in x underscore train and the corresponding target variable in y underscore train. Asterisk y underscore pred equals CLF. Predict, x underscore test. This line uses the trained decision tree model, CLF, to make predictions on the unseen test data, x underscore test. The predict method returns an array of predicted class labels. Asterisk print, accuracy, metrics, accuracy underscore score, y underscore test, y underscore pred. This line evaluates the performance of the trained model. Asterisk metrics, accuracy underscore score, y underscore test, y underscore pred. This function compares the actual target values in the test set, y underscore test, with the predicted target values, y underscore pred, and calculates the accuracy, which is the proportion of correctly classified instances. Asterisk the result, the accuracy score, is then printed to the console. In summary, this code demonstrates a basic workflow for building and evaluating a decision tree classifier for a binary classification problem, predicting diabetes. It involves loading data, splitting it into training and testing sets, training the model on the training data, making predictions on the test data, And finally, evaluating the model's accuracy. The visualized decision tree. The image below the code shows the resulting decision tree. Here's how to interpret it. Asterisk root node. The topmost node represents the starting point of the decision process. It contains asterisk the best feature to split on at this level, e.g., glucose. Asterisk the splitting condition, e.g., glucose less than equals 127.5 feet. Asterisk Gini or entropy, the impurity measure at this node. A lower value indicates more homogeneity. Asterisk samples, the number of data points that reach this node. Asterisk value, the number of samples belonging to each class, e.g., number of zeros, num.